Hey guys, this video is about expanding brackets. If you struggle with this at all, or maybe, so if you forget how to do these questions like these, simplifications like these brackets, or maybe you know how to do them, but you don't really know why you do them, you don't really know why it is the way it is, I really recommend this video for you. Not only in this video, we're going to go over how to expand brackets, but we're going to go over why we expand them the way we expand them. And this is going to make expanding brackets really easy for you, and it's going to make it, you're going to really understand it. So let's get straight into it. First of all, we'll go into actually how we expand brackets. So also with brackets, when you have two things next to each other in algebra, this means they are multiplied by each other. So if you have A, B, this is A times B, right? Cool. So when you have two brackets together, this just means x plus 3 multiplied by x plus 5, essentially. And to save the space, we don't include the multiplication sign. So the way we'd usually do this is we would take one element, the first element in this one, and multiply it by the first element here. So we'd get x times x, and we'd get x squared. And then we take the 3 and we multiply it by the x here, and we get 3x, and we add that 3x. And then we'll do this x to this 5, to this one, which is 5x. And then we'll do this 3 times the 5. And then we can simplify it. Simplify like terms, 3x plus 5x is 8x. So x squared plus 8x plus 15. Okay, so that's how you do it. But why do we do it this way? Let me show you. So more generally, what we know is that if we have a bracket a plus b, and we multiply it by c plus d, this equals ac, a times c, plus bc, b times c, plus ad, a times d, plus bd. Oh. So that's just me generalizing. That's just the general way we do it. So why? Okay. To go into this, to go into why, we're going to look at rectangles. And we're going to use things we already know to make sense of why we do this. So there's got to be a quick way of doing this. Is there an eraser? Yeah. So I promise you, this is going to be golden. Once you see this, this will never confuse you again. And what this will also do is it will build a good foundation into learning other stuff. A lot of other algebraic stuff, like completing the square or like Pythagoras' theorem, comes from really simple visual intuition. Okay. Let's say I had a rectangle. And you're going to have to promise that you're going to have to take my word that these lines are straight. It's got side length A and one side length B. Okay? Now let me extend this a little bit. Let me extend this side by adding a new side of length C. Let me extend this side here by adding a side length of length D. Cool. And then let me just join the dots up, and let me join this line down, making an even bigger rectangle. Okay. So I've got a rectangle here inside a bigger rectangle here. And we can join these lines up as well. So I've got one big rectangle, 4 small rectangles within it. Okay. So what is the area of this big rectangle? The area of the big rectangle is just length times, one side length times the other side length. So it's going to be this side length multiplied by this side length. Well, what is this side length on the left? Well, this is just A plus C. This has length C, this has length A. So this is going to be A plus C. I'm going to put it in brackets. And this is multiplied by B plus D, because this has length B and this has length D. So the area of this whole rectangle is A plus C multiplied by B plus D. But another way of thinking about the area of this rectangle is the area of all these smaller rectangles. And what is the area of each of these smaller rectangles? Well, this rectangle here is A times B, which is AB. This rectangle here is A times D, which is AD. This rectangle here is C times B, CB. And this rectangle here is C times D, CD equals CD. And so the area of this rectangle is this area times by this area, added. It's the sum of all these areas. AB plus AD plus CB plus CD. So it is AB plus AD plus CB plus CD. This is the area of the big rectangle, but this is also the area of the big rectangle. So we have that this is equal to this, because they're equal to the same thing. And coincidentally, if we do A times B, we get AB. If we do A times D, we get AD. If we do C times B, we get CB. And if we do C times D, we get CD. So this is why that is how you expand brackets, because it's really just an abstract way of looking at, if you have 4 rectangles condensed into one, the area of these 4 rectangles is the area of the big rectangle. So a last example, I suppose, would be x plus 3. So if we were to do our x plus 3 times by our x plus 5, well, this is x squared, as we saw earlier, x squared plus 3x plus 5x plus 15. If we were to look at that on our diagram to make maybe more sense of it, let me rub this out. It's taking me a while. Well, you could imagine this as you have a rectangle. Ha! That is not a rectangle. Hold on. You can imagine expanding x plus 3 multiplied by x plus 5 as having, well, this could be, or this is a square actually, because both sides have length x. You have your x plus 3 on one side. You have your x plus 5 on another. How have I done that? So the area of so I'm drawing this massive rectangle. the area of this massive rectangle is x plus 3 multiplied by x plus 5. But this is also the area of all these little rectangles summed up. This is a square. This is x times x, so it's x squared. This has length 3, this has length x, so this is 3x. This has length 5, this has length x, so this is 5x. This is length 3, this is length 15, so this is 15. Which is why you get that. So I hope that video was useful. Any questions, leave them in the comments. I'll do my best to answer them. Or any requests for new videos, do leave them in the comments. Thank you for watching, and I hope this was useful.